So let's now really quickly look at how we can install some of the packages that are associated with R. In Python, we used our conda management to install. So we said conda install, and we would install some package. Now let's look at how we do that in R. And how I'm going to do this is, first thing I'm going to do is I'm going to open R. And R is just a programming console. So this is going to open up the R console that we've seen before. So inside of our console, this is where I can actually just save any of the workspaces or something I need. So I could say, x is equal to 5 here. I could say, x is equal to x times 5, and then print out x. It's 25, right? So this is exactly the type of thing that we can use inside of our console to do intermediate analyses and to see if some what we think is going to work inside of, let's say, an R script is actually working. We can just do it straight from the console. But this is also where we can install, and it's the easiest place to manage and install the packages that we have installed. So one of the things that we might do is, let's say we wanted to install an image processing library, right? One very popular image processing library in R is called ImageMagick. So I could go to packages and data and then go over here to my package installer. And it brings up my R package installer over here. And it's essentially something that I can use to search for and install the packages that I want to use. So if I were to look for the Magick, and it's M-A-G-I-C-K, if I were to look for ImageMagick, I'm just going to get the list for this. So it's going to go out and search for where it might actually find the different packages for ImageMagick that might exist. And let's see if we can do it. There. So once it was able to populate this list, we can now search for it. And so if we look for this package, the repository name is 1.5.6. So if we want to install this package, we just have to say, okay, well, install all the dependencies as well. And now just hit install selected, and you will see some things come over here where it's actually downloading the binaries for this and installing it such that this is a package that I can use now in R. Right? And so now the whole thing is downloaded. So if I wanted to, I could say, okay, I want to be using the library here, Magick, and it would load all the required packages that I need to be using the Magick, this Magick package that I have right here, and it's already now installed on my system. In fact, even now if I go into rpy2 from a Python notebook, I will have access. I can actually call library Magick, and it will still be able to install or tell me that I'm using the Magick library inside of my code base, right? So let's do that. I don't want to save this console. So let's actually go in here and let's add some custom functionality to our calculator using R. So the first thing I'm going to do here is I'm just going to redefine how we were looking at things in Python. So I've actually created this this .py file called calculators.py, and inside of it are two classes: the custom calculator that we had created before, and also the calculator error. And these are the exact same code inside of that file. So if I were to open up calculators.py, it's just exactly the type of thing that we had written before, except now it's in a .py file rather than a Python notebook file. So inside of this, you'll see, the class calculator exists, and then the class custom calculator inherits from that calculator that we just defined above it. We've got calculator error, we've got the class operator, and everything works exactly as we had written before. So that's the only thing now that's in this calculators.py. And because of that, it's in the same directory as this IPython notebook. So I can say from calculators, import custom calculator and the calculator error. And that allows me now to use both of those in this very kind of simplified syntax. This is the exact same type of thing that we had before when we were using the calculator. So I can just run this now. Here's the operations list that we have right here. So I could enter 45, and I could say 3, and then multiply the two of them together. So I get 135. Q equals quit. So now I'm loading all of these from file that I've already written. Okay. Well, now let's do something. Let's write some functions in Python such that we're able to add custom functions, custom operators but not from file, just by defining them in code. And we'll use that later on to actually use our code to define new functions that our calculator can do. So from calculators, I'm going to import operator, the operator class, and then I'm going to define this new class called notebook calculator. It's the calculator that I'm going to run from this notebook. And it inherits from custom calculator, right? And the only thing I'm going to do here is define this function, which is add custom function. And I have to give it the function, I have to give it the key, right? I have to give it the number of arguments that it takes, and if I don't give it, it defaults to assuming that it takes one argument. And the only thing that I do here is I go into my operations list, and I create a new key in the dictionary, which is a function that I want to define, and the number of arguments that are inside that function takes, right? And so that function could be anything. I just wrap it in the operator class so that I can also look at how many arguments that function takes. So using this, we're going to define two arguments. We're going to define two different operators. The first one will define a function called power, which takes arg2 to the power arg1, right? So arg2 to the power arg1 using the power symbol that's part of Python. The second that we're going to do is actually a function which has three inputs. It has x, it has a mean, and it has a standard deviation. And the only thing I'm going to do right here is I'm actually just going to define a Gaussian function, which is basically, okay, we take x minus the mean over 2 standard deviations squared, and we take we exponentiate that, and then we divide it by the square root of 2 pi times the squared standard deviation, right? So this is just a Gaussian function that we've defined right here. But if this is a function, the operator, it takes 3 inputs. So that's something we haven't really done before. So now when we use this, I'm going to say add custom function, right? I'm going to do notebook calculator equals calc, so I have an instance. I'm going to add the custom operations from the JSON file, and then I'm going to add these other 2 functions that we just defined, power and Gaussian right here. And so if I were to run this, wrong input, sorry. We need to define this as just taking input. Some legacy Python 2 code right there. So now if I run this, I'll be able to see that I can take something. So if I enter 34 and I were to enter, let's say 2, then this is a supported operator now, this times right here, because that's what I set the key equal to for that. So now if I were to just enter times right here, well, I get 34 squared, right? So now if I have 1156 and I actually want to take a Gaussian of that, let's say the Gaussian I want to have is going to have a mean of 1 and a standard deviation of 1. Well, now I can say, oh, I've got this Gauss operator that I want to do right here. So if I take Gauss of this, I can see that if I take a Gaussian with a mean of 1, a standard deviation of 1, and place the number 1100 through it, essentially, I can see that that's a very, very low Gaussian probability on the output. Okay, and so it's been able to work now. I'm able to add these custom functions into my calculator. Okay, so now let's do this using RPy2. The first thing we'll do is we'll just load the extension RPy2. And now let me do something here where I'm going to use R, and I'm going to say, I'm going to have a Python variable called input arg name, and I'm going to input that into my R interface. So using RPy2, I'm going to say %R, use this input arg name as the input, as output, get the output arg name. And so what I'm going to do is I'm just going to say output arg name is equal to the input arg name to the 4th. So it's basically taking something to the 4th power. And this syntax right here, this almost like this reverse arrowhead, that's just legacy R code. That used to be the assignment operator. I can just replace that with an equal sign if I want to. It doesn't change what happens. So I'm going to run this line of code in R, and I'll get my output arg name, and then I can print it out. So if I were to run this line of code, I can see that it's equal to 16, right? So I take 2 to the 4th power, I get 16. But interestingly, I can actually define this inside of a function, inside of a Python function. So I'm going to define this new Python function called rfunc, and it's got an input argument. And now I'll basically use the exact same line of code that I had up here, and then return the output argument. Now it returns it as a list, so I need to just return the first element in the list that we have right here. So if I take our function and then put 4 through it, 4 to the 4th power is 256. So now I've got this function that's written in R, but I'm able to call with a Python function just using this %r magic. Okay, so let's use that to add this R function into our custom calculator, and it's very, very easy to do, where I create my notebook calculator, but now I give it the R function. I tell it that the key that I want it to use is 4th, and the number of arguments it takes is 1. So now when I run this, I'll be able to enter, let's say 3, and I can say 4th, take it to the 4th power, 3 to the 4th power, 81. Right? So pretty simple and easy to use. Okay, well, let's do something that's actually a little more interesting. Let's actually do something in R that is that's kind of more complicated, not just one line of code. So what I'm going to do here is I'm going to define a function in R. So I'm going to say function A, right? The input is A into this function, and the function name is sum underscore vector. And I'm going to say that b equals 0, right here. And then for I in 1 to A, so 1 to whatever the number that they put in here, I'm going to say b is equal to b plus I squared. And then we will return b, right? And so return b is actually just a way of saying, the very last variable that you evaluate would be returned by a function always in R, right? We could also explicitly say, return right here, and it will return b explicitly. So we can actually run this. And now we've defined this sum vector code. So this vector is always defined in our R workspace. So if I were to say %r, and I were to say, oh, okay, the output should be out, let me take out equals the sum vector of 3 right here. So I'm going to sum a vector from 1 to 3, take the squared values of each of the elements, and then print out what the output looks like. Well, it's equal to 14, right? And that's because I have 1 squared plus 2 squared plus 3 squared, right? So 9 plus 4 plus 1, so I get 14. I could wrap that inside of a Python function so that it's something we can add to our calculator, just using this notation right here. So out equals sum vector arg, and return out at the 0. And now, in the exact same way that we did before, we can add a custom function, and it's sum vector in R, which we just defined that right here. We'll call it sum vect. And it takes arguments 1, and we're able to take, basically all of the squared elements up to that number and add them together. So let's do that now, see if we can work. Okay, looks like we've got sum vect as one of the supported operations for our calculator. So I could enter something like 10 right here, and I could say, well, what's the vector sum of all of those together? It's 385. So now I'm able to call R, transition the memory back to Python, and use this kind of subsumed to the programmer and really extend the functionality of my calculator. And I now have access to any of the functions that are available in R, any of the things that I can do with. I can always wrap them in a Python function and call them specifically from here. Right? There's no reason I have to do this. I could work in R specifically if I wanted to. I could create a whole new calculator just using R if I wanted to. But it's nice to know that we can get these two programming languages to talk to one another, which can be extremely useful because they both have really lots of their benefits in using both of them.